Good morning, all of you. So in today's class, we are going to discuss the numericals on the electric dipole. In the previous class, what we had the total discussion on only on the theory, like how to find out the field and potential nearby the dipole, and thereafter we went to the torque experienced by dipole kept in an electric field, then also the interaction potential. So this was around the theoretical part in previous class. Today, now what happened? We are going to discuss about the numericals. What that numericals will be like: if two dipoles are there, what is the force of interaction? And the point charge and dipole, what is the force of interaction? If a dipole kept in a field of line charge, what is the force of interaction? Then some electric field, I'll keep a dipole. Then how to calculate the torque potential energy? Or I'll give the information of potential, electric potential in a region. Then how to get the torque or force acting on the dipole. Or like in some charger system, I'll keep a dipole. How all things will be related. So you have already all the basic textbooks are there. So try to work out numericals after this class so that you can totally wind up this topic. Now, what is the advantage of this is, what all you study this dipole, electric dipole, it is going to help you again the magnetic dipole moment in electromagnetism chapter and also the bar magnet. Three topics almost the same. Instead of here P, you'll get M there, magnetic dipole moment. Instead of electric field, magnetic field. So what all you put effort for another two topics is going to help you, like a gravitation, electrostatics, how the advantage. The similar way also. In the bar magnet also the same formulas, the same numericals. Again, current carrying loop in a magnetic field. Again, the same set of formulas. Okay, fine. So don't neglect this topic. Okay, first we'll find out the force of interaction between the dipoles. Or force of interaction, we'll write it. So let me assume I'll start with a simple, let there be a point charge Q. And here I'm going to keep a dipole. So let the dipole moment of this be P bar. So it is kept at a distance X. Usually the length of dipole will very much less than the X. This is a condition. Okay, now we have to calculate the force of interaction between this dipole and the point charge. So what is the method here? We can assume this dipole present in the field of point charge, or the point charge present in the field of dipole. What is the electric field strength due to the dipole on the axis? What is the electric field due to dipole on the axis? That should be equal to 2p by 4 pi epsilon naught x cube. Can you remember? The electric field on the axis of dipole should be 2p by 4 pi epsilon naught x cube. On the bisector, this 2 will not be there. Am I right? And then on the axis, in what direction the electric field strength will be? In the direction of dipole moment. Now, what is the force of interaction? Q into E dipole. So this will become 2pq, or say Q. Further, you can simplify this. Now, what is the assumption we made? We made assumption that the point charge present in the field of dipole. Can we do either way? I'll assume that dipole present in the field of point charge. Yes. So what you should do here? You should calculate the force acting on positive charge, force acting on negative charge. The resultant of that force should be the required answer. Okay, can you hear me? No? Voice, all of you, you are able to hear me?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Check from your side. Okay, I'll decrease the fan speed. Can you hear me now clearly?
Yes, sir.
Huh? Okay, technical side from your side, please check Yochin. Huh? Maximum from my side, technically there won't be problem. Only if internet is now there, then there'll be trouble. Otherwise, any troubles, no, check from your side only, please. Huh? Okay, there's a method of finding the force of interaction. So we can also do either way. What is that? I'll assume the field strength due to this positive point charge. Here, how it will be towards right. So here, this positive charge will experience more force than negative charge. The reason because field strength due to point charge at 1 will be more than 2. If I let me write symbol 1, 2 due to point charge E equal to KQ by x1 square, E2 equal to KQ by x2 square, x1 less than x2. So E1 greater than E2. The positive point charge is what actually experience force towards right. The negative charge, the positive charge, repulsive force it will be. Negative charge will be attractive since like a F1 will be greater than F2. So on the dipole, the force will be acting towards right. Okay, there's a very fundamental problem. So that's why I'm trying to explain using both the methods. You can see clearly, So this will experience a force F1, this will be F2. Since F1 greater than F2, so net force on the dipole will be like this. Okay, will it be attractive or repulsive? That one will be repulsive in nature. Okay, so now the concept will extend to the between two dipoles. Now, if there are two dipoles are there, we have to calculate the force of interaction between these dipoles. So this dipole moment, let it be P1, dipole momentum of this be P2. So again, the length of the dipole will be very much less than compared to the separation between them. Carry on, take your notes, notebook and try to work out. What we have to do is like, this dipole will produce field here, in what direction will be towards right. Then calculate the field strength. So let this distance be equal to, so can we assume this distance to be L? So at this location, what is the position of this point charge will be L x minus L. So the field strength here will be more than this. So they'll experience a force. The difference of that force is what? Force of interaction. You can do by that method. Let me come by the other alternative. Try that one. Find out the field strength due to this dipole at the position of this positive point charge and also this negative point charge. Let the charge be plus Q minus Q. Then calculate. Let me go for the another method. Shall we calculate interaction potential? So I'll assume that the dipole 2 is present in the field of dipole 1. So in what direction this first dipole will produce here? It will produce the field in this direction. What is the interaction potential between them? U is equal to minus P1 dot minus P2 dot E1. P2. I changed it here. So the interaction potential G, okay, it will be like this. So there's a negative charge, there's a positive charge, no? We'll put in this way, So now this will become U is equal to, what is the angle between them? 180 degrees. So P2 E1 cos 180. So this will become P2 E1. Cos of 180 will be -1. So this will get the interaction potential energy. Now what is E1? E1 should be equal to 2p1 4 pi epsilon naught x cube. So this will become p1 p2 by 2 pi epsilon naught x cube. I know potential G. Let me differentiate this. du by dx. This should be equal to -3. This 2, let it be there. Huh? So -3 2p1 p2 by 4 pi epsilon naught x to power of 4. Will I agree this? X to power of -3, the derivative of this u, what happened, du by dx, will get it. We know the force F should be equal to minus du by dx. So minus du by dx will become 6 p1 p2 4 pi epsilon naught x to power of 4. I got directly F positive. What do you mean by that? If F positive, it will be repulsive. If F negative, it will be attractive. So what these dipoles are trying to do now, that they'll, they'll exert a repulsive force on each other. This is applicable for only conservative field. This equation is applicable only for conservative fields. I am making a very strict condition. Now, similarly, if the dipoles are, look at how the electric dipole moment, they are in same direction. No? If the electric dipole moments are, so like they are in opposite direction. If the electric dipole moments are in same direction, what conditions will arise? Slightly, I'll change the diagram. Anything now? Yes. What about the force of interaction in this case? Will be attractive, no? F will be negative. In fact, you check it, calculate, no, F will come negative. So again, the force of interaction will be F. This will be F. So how much F is equal to 6 P1 P2 4 pi epsilon naught x to power of 4. Solve it mathematically, will end up with negative sign. So it's attractive. If you end up with positive sign, it'll be repulsive. Then how do this force of interaction proportional to 1 by x to power of 4? Very important for exams, do remember. The force of interaction between dipoles is proportional to 1 by x to power of 4. I think this will be better, easier method where I'm bringing some energy idea. Or else, what is other alternative? The other alternative is like, you know the field strength here, how much E1. Then, so for a small distance dx, so instead of this L, no, you write it as dx. Then, if the distance slightly decreases, then field strength here will increase. Then similarly here, the field strength, what happens, should decrease, here increase. So these two will experience a different force. The difference of that two forces is what we got this particular thing. So I think in books they have shown that method also. If you are interested, try to think on that. I'm just taking help of the energy method. Any doubts, you can clarify. Okay, I'll go to the next thing. So if the dipoles, if they are so this having a dipole moment P1, this having a dipole moment P2. We have to calculate the force of interaction between these two dipoles. What is the method? So what you can do? So you'll assume that the second dipole present in the field of first dipole. So what is this? This line will become now bisector. Am I right? That this blue color line, what I'm drawing, will become bisector. So now the field strength at this point, you know, in what direction it'll be towards left E1. Then slightly at a distance here. So write this dx and dx. So calculate the field strength here and here. I think it'll be very lengthy approach. We know on the bisector, but somewhere at this point, again, we have to jump into mathematics. So rather than that particular lengthy method, what is the other alternative? We'll assume that this dipole 2 present in the field of dipole 1. So how the electric field strength here will be directed in this way. Is it okay, justified? Yesterday we have seen, no, like on the bisector, how the field strength should be directed opposite to electric dipole moment. Then the interaction potential between them should be equal to P2 dot E1 bar. So this should become P2 E1 cos 180. So interaction potential is P2 into E1. What is E1? Should be equal to P1 by 4 pi epsilon naught y cube. Again, I'm going to differentiate. So du by dy. This should be equal to P1, P2, 4 pi epsilon naught KPTL minus 3 by y2 power of 4. So this will become minus 3 P1, P2, 4 pi epsilon naught y2 power of 4. Or minus du by dy So this should be equal to the force F. What about the repulsive or attractive? F is positive. So therefore there will be like a repulsive force will be set up on them. In what direction? It will be in this direction. The forces acting will be in this direction. No, not along x-axis. They will try to move away. So similarly, if the dipoles, if they are aligned, no, what about the force? The force will be now attractive in nature. Check it. Attractive force, mutual attractive force between dipoles. Mutual repulsive force between dipoles. Got the idea, no? We are totally dependent on mathematics, like F positive, okay, it will be repulsive, F negative will be attractive, or else, no, sir, I'm not getting. So what you should do, assume that, find out the field strength at this location of this positive point charge due to dipole 1. Calculate the net force. Similarly, find out the field strength, magnitude and direction at the location of this negative point charge. Calculate the force. Take the vector sum of that, then you can conclude. If you want to try manually, finally you'll end up with the same thing. Okay, no. So I'll trouble you with the next condition. Let's see that how student will analyze. So how suppose let me keep the dipoles in a very random way. Oh. I'll just put instead of every time drawing dipole, no, let me show with the arrow. Okay, there's a one symbol what we usually take help of this one. The other dipole somewhere here. Okay, this is the theta. It is making some angle alpha. How to manage this? I want first the interaction potential G. Then can we discuss anything about the force? First, let me calculate interaction potential. We'll see that can we find out even the force of interaction? We'll check it. Let this be R. They are short dipoles. Huh? Two short dipoles are lying in XY plane as shown. Find interaction potential energy between them. What all I just now explained, really you can take help of that one. What is the method here? I want directly interaction potential. Can we calculate the field strength at this point? I should know the field strength here. No? So what is the method to calculate the field strength? I have a dipole here. What is the method? I'll calculate E parallel. Then I'll calculate E perpendicular. Got it? No? So how to calculate E parallel? Already we have formula. And E perpendicular also we have formula. Then I'll calculate the resultant field. That will make angle phi. And directly we know what is tan phi should be equal to tan theta by 2. So there's no problem with angle. Whatever the magnitude, directly we know that also magnitude. How to calculate the magnitude? P by 4 pi epsilon naught R cube by 1 plus 3 cos square theta. Is I'm right from the yesterday's discussion what all we made, no? So now we know magnitude and direction. Okay, now I'll assume that the second dipole is present. I want you to please try once rather than me concluding directly, no? I want students to work out once. So I'll directly take help of this situation. Okay, if we have a dipole P1 and this angle theta. So what we do is like we'll get first E parallel, E perpendicular, and the resultant E bar. The resultant E bar is what? That angle phi. Phi or any other angles if you want, you can tell. Let me take it phi only. No, I think we know enough of this one. Directly, let me go for the E bar. What is the resultant E? This should be equal to P by 4 pi epsilon naught R cube three cos square theta. Then the angle phi is given by tan theta by 2. I know the dipole moment P2 is making, but we wanted some sort of like a vector, no? So therefore I think, okay, this is fine to some extent, but I suggest you like, rather than this may not help you. Am I right? Because we wanted the interaction potential. So therefore what I do is like, though we know these formulas, okay, just they may not help us. I'll assume that I'll remove this E bar also. Here I'll bring the dipole. I think this will be much very clear. Now we'll calculate the dipole present in the field of this. We'll calculate interaction potential and also due to these two, we'll add up, we'll get the required answer. Getting the method, you have to take help of here mathematics here. So rather than fighting with any of the concept. Let me begin here. the total interaction potential G should be equal to, U should be equal to P2 E parallel cos alpha. I'll write in vector form first. This will be P2 bar dot E parallel plus P2 bar dot E perpendicular. Minus of this should be there, no? Yeah. No. P2 E parallel cos alpha. P2 E perpendicular. What is the angle between them? Cos of 90 minus alpha. Anybody? Cos of 90 minus alpha? Sin alpha? Okay, good man. Yeah, thank you. Keep it here. So now I think we are in better position. Do we know what is E parallel? E parallel should be equal to 2 P1 cos theta by 4 pi epsilon naught r cube, and this is cos alpha. P2 E perpendicular. E perpendicular will be P sin theta sin alpha. This is the total interaction potential. Let me simplify the steps. So 2 P1 P2 cos theta cos alpha P1 is missing. P1 P2 sin theta sin alpha. Okay, agree this. So not only in some specific position, in any arbitrary position, let they be oriented, we can work out. So I think we have to be a little bit careful the way we are going to deal. So we have to make the problem very simple. Okay, better go for this approach. So I know the component of electric field at the location of dipole 2 due to dipole 1. So that is E parallel, E perpendicular. I'll assume that dipole P2 present in these components. Okay, I agree this approach. Can we calculate force of interaction? Differentiating this, we'll get only magnitude, not direction. Am I right? Differentiating this, what happened? We'll get the magnitude of force. Or else, so what happened due to this, due to this component, P2 cos alpha, due to this component, you'll get X component of force. Due to this component, you'll get the perpendicular component force. Take the resultant of that and you'll get somewhere in some direction. Differentiating this will get the force of interaction. They may not trouble you because may not be very important. None of the books also have, just I asked you. So let me put it here. F equal to minus du by dr. Will be attractive. The force of interaction will be attractive because we'll get negative. F will be negative finally. Just see once. I'll go to the next application part. Now, if sometimes you may end up a situation of this kind of, the dipole will not be along x-axis. Intentionally, I'll align dipole like this. Is a short dipole. Intentionally, let me align this dipole in this way. I'll make a little bit bigger. Yeah. So somewhere at this particular point R, okay, let this be theta 1, theta 2, this is theta 1. Or the total angle, yeah, theta 1. I want at this particular point A, the electric field strength. Look at the dipole, how it is. It is making some angle theta 1 with the positive x-axis, no? Or 90 minus theta 1 with negative y-axis. How to manage this? Let's a bit, I'll change this one. So it'll be this one. Let me make it. Yeah, so somewhere here at this particular point A, the dipole moment, the electric field strength due to this dipole has to be determined. So where this will make an angle theta 2. How to manage this one? So I'll go for some other approach. What is that? Component of dipole moment along the R bar and component of dipole moment perpendicular to R bar. Even this approach also is going to help you a lot. So this is that line. So here, so what we do is like a one component of dipole moment will be there along this. P parallel, right? The other component, I'll assume it to be perpendicular to this. The dipole moment also we can resolve, not that only electric field. This angle, we know that this angle is how much? It was theta 1, theta 2, no? This is the reference line. So what is P parallel? The P parallel should be equal to P into cos theta 1 plus theta 2. P perpendicular will be P sine of theta 1 plus theta 2. Now at a distance R, here I want the field. So now due to P parallel, how it will be? Like it's as good as this is one dipole, this is one dipole, no? And the point A is here. Where the point A? Point A is on the axis of a dipole moment P parallel. Getting the method? Similarly, point A is now where? It is on the bisector of the dipole moment P perpendicular. And we know how to calculate the field. So this will be due to, let me write due to this, let me write E1. This will be E2. E parallel, E part, not due to one, due to this, or I think this will be more confusion for you. E dash, E double dash, I'll write. What is E dash? E dash is due to only P parallel at point A. What about E perpendicular, like E double dash? E double dash is like a due to P perpendicular. So what are the values? E dash should be equal to 2P parallel 4 pi epsilon naught R cube. What about E double dash should be equal to only P perpendicular 4 pi epsilon naught R cube. What is the resultant E bar? Should be, I think this will be much easier method, no? And substitute P parallel, P perpendicular with these values. So you can use any of the alternative methods available for you. Getting some, all these are skills. Now we know concept. All these are the skills. You can resolve even dipole moment also according to your requirement. Anybody having doubt, you can clarify. So why I'm discussing this problem? I just saw one numerical of this kind. There's a charge plus Q and is asking find the dipole moment somewhere here where this will make an angle theta, where this R is very much greater than, I'll write it. Now I think the approach what I given will really going to help you a lot. R very much greater than L. So you have to find out the field strength at point A. Tell me what you're going to do due to this point charges. What is the method? So first due to, okay sir, what I do is like due to this plus 2q charge, the field will be somewhere here. Due to positive charge will be here. Due to negative charge somewhere in this direction. Then I'll take the vector sum. Very, very lengthy. Instead, we can go for dipole moment concept because of this condition given. So here, what shall I do now? I'll treat this as one dipole. So there's one dipole is there of dipole moment LQ and the other dipole moment of L2Q. The resultant vector sum, I'll get it. Please do learn these methods. These are very important. Dipole is not just about the formulas. This is one dipole, P2. There's another dipole. I'll get P1. What is P1? P1 should be equal to L into 2Q. This minus 3Q charge, shall I break up? Minus 2Q plus 2Q minus Q and plus Q. And what about P2 should be L into Q. The vector sum of this, how it will be? It should be near. Okay, let this make an angle alpha. So can we calculate the resultant dipole moment? P is equal to P1 square plus P2 square. That we got it. Can we get alpha? Tan alpha equal to P2 by P1. That should be equal to 2. Okay, I got the alpha. Now, where is the point? The point where is asking to calculate field. No, it is somewhere here. No. Again, what is your approach?
Tan alpha is 1 by 2.
Tan alpha?
P2 by P1 is 1 by 2.
1 by 2.
1 by 2, huh? Okay, 1 by 2. I'll make changes here. Yeah. Okay, I got alpha. So I'll give the value of theta. Now I want the field strength at point A. So tell me what shall I do? Again, I'm going to resolve P cos of theta minus alpha. The dipole moment of that will be along this R bar. P sine of theta minus alpha will be perpendicular to that. Then I'll get the fields. I'll take the vector sum. I'll get the resultant field. Or else calculate the angle between R bar and P bar. Substitute in that formula. Any of the approach. Able to make it out? I'm just sharing the idea. We'll take the next set of numericals. It's a very small topic, but a lot of troublesome things are there. Let me introduce to the next set of questions. A tiny electric dipole P bar equal to P naught J cap is placed at point L comma 0. There exists an electric field E bar is equal to 2a x square I cap find force on the dipole. Okay, he has brought it. Look at the dipole moment. Its magnitude is P naught and it is aligned along y-axis. And in that region, there's electric field vector is there, 2a x square I cap plus 2b y square plus 2cy. Is asking you to calculate the force on the dipole. Earlier we were knowing we were calculating the field that one. So now we'll look at the field uniform or non-uniform. Non-uniform, no. So we'll directly take some method before going to the solving such numericals. No, we'll analyze. So what we have is u equal to minus p bar dot e bar. I'll differentiate this. All of you, please concentrate. Can I do like this? What is du by dr is what force. So there should be a minus of du by dr equal to r dot minus of du by dr should be equal to f bar equal to p bar dot de bar by dr bar or dr. No. To get x component of force, you can write it as p bar dot de bar by dx. To get y component of force, p bar dot de bar by dy. If there is a z component of force, p bar dot de bar by dz. We can think in this way also. Earlier, we were bothered with only one direction. Now, if the field exists in a space or three-dimensional, two-dimensional field, then this approach will be better idea for us. Okay, now I think straight away come to the formula. So this is the idea now. Now, please remember your teacher is trying to give some certain thing. So these things is what you should revise for exam. Just an idea. So let me, I want the total force. So there are two components of forces are there, no? One x component and the y component. Directly substitute here, I'll work out. Okay, first let's go for the x component. Fx equal to px bar dot de bar by dx. What is the x component of dipole moment? 0, because the dipole moment is along y-axis. Are you looking at this? So this will be 0. The derivative of this will be 4a x I cap. And anything multiplied with 0 will be 0. So there's no x component of force acting on the dipole. Similarly, Fy bar equal to Py bar. Sorry. This is I just made some correction. Just see this one. Dipole moment, its component along that field has to be taken. Then you'll get the Fx. Now this will be P bar dot de bar by dy. What is the component? P naught j cap dot. Derivative of this will be 4 by plus 2c. P naught 4 bvy plus 2c. Dot product. Okay, so some look at once. The only magnitude we are able to. Dot product of two vectors should be a scalar. Only the magnitude I'm able to get, and this fx will indicate the direction. I need not to bother. No, fx bar I need not write because dot product is there. Huh? Okay, no. Where is asking? Place that L comma 0. Now, why has become 0? Because it was asked at this particular point, no? L comma 0. So y coordinate is 0. I think this will be better approach, no? Or else what you should do? What is the alternative method? To calculate the force, what is the alternative? Because we don't have that. A short dipole is stilling. So can we break up this dipole into positive charge, negative charge, then force explained by positive charge, then by negative charge will be very lengthy because we don't have that information also. There's the only alternative available for us. Short dipole kept in electric field, no? So don't assume that the dipole made up of positive charge, negative charge, then force explained by positive charge, force explained by negative charge, then I'll take vector sum. Not possible here. Better accept this one only. Any doubt you can clarify? Similarly, instead of let me give the potential function. Let me write another one. Electric potential in a region is given by V of x equal to 4 plus 5x squared. A dipole is placed at position -1, 0 with dipole moment p bar pointing along positive y direction. Okay, is asking what about the net force and net torque? Now look at the potential v of x we have. So if they give potential, what shall we do? We'll calculate the electric field. E of x should be equal to minus dv by dou v by dou, or dv by dx. So this will become equal to minus of 10x. So what should be the direction? 10x, is it uniform or non-uniform electric field? Let it be non-uniform electric field. Then it's asking the force acting on the dipole kept at this particular point. How to check the force and torque? Okay, find force and torque acting on dipole. How to do this? Say roughly have an idea how the field is along x-axis. So let me do one thing. Let me bring the origin at least. So where the dipole is kept at -1 with this one. So the dipole is somewhere here. Positive charge, negative charge. Okay. Then what about the at x equal to -1? What should be the magnitude of electric field? Should be towards right. So the field here will be towards right. So this particular force, so the field here, this positive charge will experience force in this direction. Negative charge will experience force in this direction. And what about those two forces will be equal and opposite? So net force will be 0. What about torque? Torque will be non-zero. There'll be torque acting here. So net force will be 0. Net torque non-zero. Getting some idea? This one? Put x equal to -1. The field here will be towards right. So positive charge will experience force towards right, negative charge towards left. Simple objective question, very troublesome because students that is our potential what to do. Okay, from potential get electric field, the dipole is present in electric field and analyze it. in an electric dipole moment, P bar equal to microcoulomb meter is placed in an uniform electric field, E bar equal to 2I cap, sorry, cap plus 2K cap (10 to power of 5 Newton Coulomb). So what all you have to calculate? You have to calculate the torque and potential energy. Find torque and U. Okay, instead of giving that something, no, I'll give that in the vector form. I think this will be very simple, no? So what is the formula? Torque equal to P bar cross E bar. You know, it's not addition, cross product. I cross I will be 0. K cross I will be J. I cross K will be minus J. So minus 4 J cap. Then J cross I will be minus K. I cross J will be K. So minus. No, similarly, J cross K will be I. So this will be plus 6I. So the torque will be plus 6I cap minus 4J cap minus 9K cap. Newton per meter. Similarly, the potential energy, the formula will be P bar dot E bar. P bar will be 2I cap plus 3J cap dot I dot I1 6, I dot K will be 0, J dot I will be 0, J dot K will be 0. Minus of no, minus 6 joule. Some problems on the vector based.
Sir,
Ama.
it's given in centimeters, sir.
Huh?
It's given in centimeters.
Oh, convert into. We have to convert this into micro, no? .1 will come. Huh? Check it. The units I adjusted in this way. Because 10 to power of 5, 10 to power of 5.
Meters only, no, sir. Microcoulomb meter.
Microcoulomb meter, not centimeter. This is this one. So here 10 to power of minus 6 and 10 to power of 5 will be there. So 10 to power of minus 1 should come. That I adjusted. I think it's correct now. Not centimeter, my it's a dipole moment, no? Coulomb meter.
Yes, sir.
And it will be method. So here also I think 0.6 will come. When you put that 10 to power of this one, 0.6 joule, it will be. Okay, some vector based this one, so can also be of this kind. So you just be alert. Huh? Okay, let me go for the next condition. I have a this will be negatively charged. This arc will be positively charged. I want the dipole at linear charge density be plus lambda minus lambda. I want the electric dipole moment of this particular charged ring, semicircular ring. Earlier it was a point charge, no? Now we'll extend for certain bodies. Find the dipole moment of the charged system. Okay, I want you to put effort. But we did for only point charge, no? Something the way it's bringing. So I am. So now I'll say what is the advantage of this? I'll ask you find the field strength here. What you're going to do. So what is my primary question? What is the field strength at this point? Somewhere in the XY plane, somewhere at this point. Very difficult with the help of mathematics or integration, what we know. So with the help of dipole moment, it becomes very simple. I'll replace this everything semicircular ring with an effective dipole moment. Then I can easily calculate field anywhere here. I'll give 3 minutes time because it's something related to integration. So a student has to put effort. Take your pen notes, notebook and pen, try to work out. Now, what is the method for this? We have to calculate the equivalent dipole momentum of the system. Oh, what happened? Let me take a bigger diagram. Yeah. Okay, there's a thing, no? So let me erase this part. Now what we'll do is like, so slowly I'll change conditions. First we'll go for the basic thing. So let me assume a small element. Here I'll assume one element. Here I'll assume one element. And then it will be, you can see it here now. So this will be the theta. This will be theta. These elements, let it subtend an angle d theta. Let the charge be dq minus dq. So I think these together will make a dipole, and there's a distance between them. So what is the radius r? This is r. What is the distance of separation between this minus dq and plus dq is equal to r sine theta. This will be opposite, no? R sine theta. And what is the amount of charge dq? So what is the dipole moment of this system will be dp is equal to 2r sine theta into dq. 2r sine theta. This is r sine theta, r sine theta. For your convenience, I'm writing it. Okay, now we define the dipole moment. So what is dq after this? So 2r sine theta. dq, what we can write, lambda into ds. What is ds? R d theta. So 2 lambda r square sine theta d theta. Let me integrate. 2 lambda r square sine theta d theta. What should be the limit? 0 to pi by 2. Because since I assume two elements, 0 to pi by 2. If I assume only one element, it'll be a little bit difficult. We can't do that one. Or shall I assume minus pi by 2 to plus pi by 2? Or 0 to pi? Let me talk to all of you. 0 to pi by 2, if you assume it, then you'll get the total dipole momentum of this semicircular ring. So this should be equal to P equal to 2 lambda r square minus cos theta, 0 to pi by 2. So 2 lambda r square. What is lambda? Lambda, further, if you want, you can write it a charge. Okay, linear charge density, I defined it. This will be the dipole momentum of this system. How it will be directed? How it will be directed? Along x-axis only. Can it make a dipole moment first of all? Will it make a really dipole moment? Yes, it will make a dipole moment. Like this, you may end up questions of this one. Don't think that only point charges will make dipole moment. Even the semicircular ring, now it's a dipole moment. See, now I got this. Sir, where you are going to place this dipole? Where I should place? Actually, the charge will have a mass. I should place exactly at the center of mass, not at origin. Please do remember. Of course, we don't go for that level. This particular effective dipole moment, short dipole, you have to place at center of mass, not at origin. Because do I integrate a 0 to pi by 2, you have to place it center of mass. Then if I ask you anywhere field, as I can calculate. So now I think we are in better position. I'll ask you to find out the field here. I'll replace this with a dipole at short dipole at center of mass. And from there, what happened? I'll discuss the problem. This is what actually the necessity of this dipole concept. Like this is going to help us. It will minimize some mathematics here to some extent. Okay, this is about the negative positive charge. Slightly, let me change the problem. The same condition. So this everything is positively charged semicircular ring. Linear charge density lambda. I am going to keep a point charge, negative point charge here. I'll write again here also. So I want the dipole momentum of system. Find the effective dipole moment of system. Carry on, no? It's a semicircular ring. Semicircular ring. No, earlier it was quarter ring was positively charged, other quarter was negatively charged. But here the total ring is positively charged. I'll keep a point charge. How come? Yes, they will make a dipole. We have to calculate that particular. So again, I'm going to assume there's a diagram. No, let me take the another one for working. Yeah, so we'll assume the similar idea. Red color. Oh. No, the same similar method, what we did. This will be theta, theta, d theta, d theta. Together, these two will make one dipole. Together, these two will make one dipole. It will make one dipole. This will make one dipole. So dp, I'll write it. dp dash, dp dash. Very simple. Don't get trouble yourself. So what is dp dash? First, let me define dp dash. dp dash should be equal to separation between them is r into dq, no? But the amount of charge is not same, no? How do we can define? Amount is charge is not same. Actually, here I'll put a condition q by 2 pi. Then only it is valid. Huh? The total charge on the semicircular ring should be equal to positive charge. If this amount of charge is different, because this cannot be dipole. I just brought this condition so that student can, this cannot be dipole. Sir, what is the reason? See, to be frank, there's no such a dipoles of this kind. Usually it will be like the atom itself is a dipole. So how it is possible atom positive charge will be like this and negative charge will be here? I don't know, some teachers like me have created such problems, but basically what when an atom is a dipole, the positive charge of nucleus is the charge of nucleus is one positive charge, and revolving electrons will become one negative charge. These are just like to make students to analyze what when we have brought all these problems here. This cannot be dipole. Fine. So therefore, definitely, if I want to ask anything question, no, what is the lambda? I should define it back like this. Got this idea? The total charge on this should be equal to equivalent opposite of this. Then only dipole moment is possible. Otherwise, not possible. They may trouble you questions of this kind. Just I gave lambda, then I change it to q. Otherwise, we can't write. Okay, there's a dp dash. Now, what is dq further? dq should be equal to dq should be equal to lambda r into lambda into ds. So r into lambda ds will be r d theta. Resultant dipole moment should be equal to 2 dp dash cos theta. 2 lambda r square d theta cos theta. D theta, okay, this will be again 0 to pi by 2. So 2 lambda r square sine theta 0 to pi by 2. I think this will become 2 lambda r square. What is lambda? Lambda we defined as q by 2 pi r. I should substitute back. 2. What is lambda? Q by 2 pi r. This r square. So this will become q r by pi. This is the net dipole moment. How it will be directed? Along y-axis. Okay, wait one. So there's some correction is there. Semicircular ring, no? Pi r will be the circumference length. So this will be the net dipole momentum of the system. Okay, fine. So these are some very important, so like only in the numericals, what when we can analyze here. The dipole, the two charges should be equal and opposite. That's a very important condition. Otherwise, Q1 minus Q1 plus Q2 can never become dipole. It's not possible. Let me trouble you with one more question. I have a charger ring. So this will be positively charged, this off. The other off will be negatively charged. Okay, this ring is having R, it's having a mass M. The charge, let it be linear charge density be plus lambda, here minus lambda. Then an uniform electrostatic field strength is applied. While the direction of E bar is switched on. So I want instantaneous angular acceleration. I'm taking you to some rotational mechanics here. Uniformly charged ring with the charge density on left off and the right off are as shown, and a uniform electric field is switched on. Gravity free space, we can assume, no gravity here. So I want the instantaneous angular acceleration. And this will be 0. Okay, let me put it here in this way. This will be very interesting. It will become how the electric field, uniform electric field, directed vertically down. I think I'll adjust the arrows properly. This will be better. Take the question, find the instantaneous angular acceleration of charged ring kept in an uniform electric field. So mass of the ring be M, mass of ring let M be mass, lambda be linear charge density. Carry on. Just now I gave idea, no? So that is what you have to apply. Let me have water. Try for this. Just some rotation mechanics idea is what you have to introduce here. This approach.
Sir, is it 4 lambda E by M, sir?
4 lambda E by M. Okay, nice. Huh? Let me try. I too don't answer. I just made a guess. No. this ring, no? So can we replace this ring with a dipole moment, equivalent dipole moment? That will be better idea. So I'll ask you your suggestions. Like, shall we do one thing? We'll find out. We'll assume a element here. I'll assume a small element here. I'll assume a small element here. Then I'll calculate the torque. Or shall I replace this with a resultant dipole moment? Then I'll go for it. Resultant dipole moment will be better idea, no? Or else you can avoid dipole moment. Straight away, what you can do, you can take help of the elements. You assume one element here and one element here. Then calculate the torque. The force will be acting here. So you assume one element here, one element here. Again, symmetric elements, you assume it. Calculate the force acting on it. Let me replace the. So these two will make one dipole. Similarly, these two will make one dipole. These two pair. So this will be theta, theta r. This will be theta, theta. This is radius r. That lambda, I'll remove it, time being. So this will be minus dq, minus dq plus dq. This will make one dipole. Am I right? Similarly, this will make one dipole. Just now we have discussed, no? Okay, can you remember? This will be like a previous problem. What was the dipole momentum of this half part? I have your answer also still. 2 lambda square. Two lambda square. This is what directly I need not to struggle once again. So for half part 2 lambda square, this 2 lambda square will be 4 lambda r square is what the resultant dipole moment. So here the net dipole momentum of this ring will be how much it is equal to 4 lambda r square. And how is the electric field vector? The electric field vector is in this direction. What is the angle between these two? So torque equal to P bar cross E, or PE, angle between them is 90 degrees. Magnitude, I'm writing it. So what is the dipole moment? 4 lambda r square into E. This is a torque that is acting. Then I want angular acceleration, torque by I. About which axis it will rotate. How to decide axis? How to bring the moment about an axis passing through about Z axis? Shall I say it will rotate? See, P bar cross E bar, curl fingers from P bar, right hand. You can take right hand, curl from P bar, from X towards Y axis, you curl it. Then how your thumb will be along that axis. How you take vectors from P bar is I cap, E bar is J cap, I cross J will be K. So the torque will be acting along positive Z axis. I think some of you are asking, sir, how to take torque? Might have forgotten. So this will be 4 lambda r square I cap E J cap. I cross J will be K. So fine. So the ring will rotate about. So the ring rotates about Z axis. So then what is the moment of inertia? Iz. Let me write it, alpha Z. This should be equal to moment of inertia of the ring, mr square. So that will cancel out. So angular acceleration will be 4 lambda E by M. Definitely, I'm more interested in asking such questions, application based, the dipole moment and the idea of the torque from rotation mechanics. all of you. So just see that the way the questions can be asked, the mixed concept. These are some examples is what I'm just sharing in front of you. So let's take one more. Positively charged an electric dipole, short electric dipole is kept radius of the ring is that one. I'll describe the question. A short dipole is kept at center of charged ring plus q comma m with dipole moment along the axis. With dipole moment along the axis. So I want the force of interaction between them. Find the force of interaction between them. Dipole and charge ring, you see there's some very nice condition is what being brought. Able to make it out? How the dipole moment will be perpendicular to plane of ring. I think you should be able to imagine like the dipole is along the axis. And what is the plane of the ring? YZ plane. Plane of the ring is YZ plane. This is the x-axis. Some are getting confusion. I'll write it here. Plane of the ring is this x-axis. The dipole moment is along x-axis here. Anybody answer? Oh, no. Shall we say that the ring is present on the bisector, three-dimensional? Try to assume that one. Try to make assumption. So I'll do one thing. Let's make a problem like this. And the dipole is present here. And now I think at least you can imagine now. So if it is here, if the dipole, let me keep it here, is a short dipole, how the field, this will become like a bisector, am I right? This will be the axis of the dipole. This will become bisector, no? This will become bisector. So how the field here will be? The field everywhere will be opposite to P bar. But sir, bisector on the bisector, okay, but you are showing arrow everywhere. I think better imagine three-dimensional diagram here, because every point on the ring will be on the bisector only. Bisector will not be only one line. In a plane diagram, there'll be only y-axis. But here, if you hold a dipole, if you draw a circle of radius y, then all points on that circle will become bisector. Am I right? So we know what is the field strength due to dipole. This should be equal to P by 4 pi epsilon naught r cube. Then what is the force of interaction? What is the total charge on the ring? Q into E. So QP by 4 pi epsilon naught r cube. Okay. Three-dimensional diagram. Huh.
Sir, if the given dipole is also along the yz plane, then how to calculate the force of interaction, sir?
Given dipole is also in
Along the yz plane.
if it is YZ plane, I think now the E bar will not be everywhere parallel to that one, no? Then
Yes,
we should assume a small element at different point, the E bar will be different.
Yes, sir.
Little bit mathematics, huh?
Yes, sir.
Huh?
Yes, sir. Should take a small element and should calculate.
Then you should integrate. Then you should calculate angle between R bar and E bar. It will be very in the calculation, not possible in Cartesian coordinate. Polar coordinate may be possible. Huh?
Yes, sir.
Okay, so some 3D diagrams. Just be careful. Huh? Okay, let me go for one more. I'm trying to share a very generalized ideas. I have three dipoles. Three identical dipoles are there. No, okay. I think okay, they're identical. Huh? The separation between them is D. External agent, what will do? It will come and rotate one of the dipole. With separation between them remaining same, is going to rotate one of the dipole. Can we rotate? Yeah. Find the work done. There's the initial. There's the final. Find the work done by an external agent in rotating the third dipole through angle 180 degree the first and second dipole are fixed. Okay, work done by exchange agent. What to do in this case now? Okay, we are able to calculate the field and the potential, something exchange agent will come and rotate one of the dipoles. So how much of work it should do to achieve this one? So what shall we do is we'll calculate the initial interaction potential. So let me give the dipoles number 1, 2, and 3. The question is very beautifully asked because we were dealing with only 2 dipole. First, we started with one dipole, then I brought 2 dipole. Now I am bringing here more than 2 dipole. I think even n dipoles come, you can manage with this question. Am I right? Try to compare things so that will be on more safer side. Books often they just confine to 1 or 2 dipole. I just made more than 2 dipole. We can extend this concept even for n dipoles. First, initial interaction potential you will calculate, that is UI. What is this one? I think what we did for the charges, no, here for dipole also we can bring this concept like a initial interaction potential between 1, 2, 1, 3, and 2, 3. What is between 1, 2? How to calculate? I'll assume that the second dipole present in the field of first dipole. The dipoles are short. There's one more condition. The dipoles are short. All the dipoles, assume all are short dipole. Okay, there's a basic condition. What is the methodology? I'll assume that second dipole present in the field of first dipole. I'll calculate interaction potential G. And what is the distance? So this second dipole is present on the bisector. How E bar will be here. All of you can see screen? No problem. Shall I continue?
Yes, sir.
Okay, yeah, fine. Now, how to calculate interaction potential between 1, 2. So this will become, shall I draw a diagram, or looking at this only I'll write down directly because already we discussed no interaction potential between 1 and 2 I'm asking. So that should be equal to P into E. Why there's no negative sign? Because how E bar will be, okay, so some of you are asking, sir, how you're writing. Let me, if there are 2 dipoles are there, this is a dipole 1, 2. So how the field due to first dipole here will be in this direction, E1. This is second dipole. So what is the interaction potential? It will be minus P bar dot E1 bar. So this should be equal to minus P E1 cos 180. Should be equal to just P E1. I think that this will be a better idea. What is electric field? Let's write that also. That should be equal to how much? P by 4 pi epsilon naught B. On the bisector, okay, D cube, sorry. 4 pi epsilon naught D cube it will become. Okay, let's write all the things. So this should become finally equal to P square by 4 pi epsilon naught D cube. The interaction potential between 1 and 3. Now what change you are going to make it? Only in place of 2D whole cube it will come, no? So the interaction potential between 1 and 3, how much it should be equal to? P square 4 pi epsilon naught 2D whole cube. So if you call this as U, then how much it should be? U by 8. Please don't mess up so many things. make it generalized. The interaction potentially between 1 and 2, if it is u, between 1 and 3, it will be u by 8. So I'll take it out all. In the end, I'll substitute this one. This is u. This will be u by 8. What about u 2, 3? Should be u. So initially, how much it is? 17 u by 8. Able to make it out? Final interaction potential. I think we have to be a little bit careful. The third dipole is being rotated. Let me try to wind up everything here only. For third dipole, okay, this is 3, this is 1. Shall we write u12 should be equal to u12 will be same, no? Only 1, 3 will change. Is it okay? Only 1, 3 will become minus u by 8. So this will become 17 u by 8. No, final potential u12 dash, u13 dash, u23 dash. No change in 1 and 2. As usual, 1 and 2 will remain same. And now there'll be change between 1 and 3. How much it will be? Minus u by 8. U23 will be minus u. Minus u by 8 it comes. So what is work done by extra agent? Work done by extra agent should be equal to uf minus ui. What is uf? Minus u by 8 minus of 17 u by 8. Minus of 18 u by 8. 18 will be 9 by 4. What is value of u? P square 4 pi epsilon naught dq minus 9 p square by 16 pi epsilon naught dq. Okay, this is a work done by external agent. More than 2 dipole, yes, it can be done. Now, any number of dipoles I can introduce here finally. Okay, just see once. I'll go to the next one more last problem. Let me take the one more. Four point charges. 4 point charges plus q are fixed at corners of a base of a square pyramid with a slant length a a charge minus q is fixed at point O fixed at point O, a dipole with a dipole moment is placed at the center of base and perpendicular to the plane of the base, perpendicular to its plane. What you have to calculate? Find the force on the dipole and potential energy of system. Okay, let me try to give the diagram. Oh, well, I can draw a better diagram. Slant phase. At the center, a dipole is kept. Here, I think the negative charge is there. At these points, positive charge. Here is what a dipole is kept. So the dipole exactly, I think this will be the axis. Fixed at a minus charge is fixed at O. So this is O. Okay, let me give the number A, B, C, D. Okay, here a dipole is kept of dipole moment P. The slant length is giving, this will be slant length. And this is side length. This is a pyramid of square base. How the dipole moment will be along the height of the pyramid. So that this will be the height of the pyramid, no? Okay, it's asking find the force on the dipole and also the potential energy of system. Now look at this. So can these negative charge and positive charges, can they make dipole? This height of the dipole is given, sorry, height of the pyramid given A by root 2. Tell me what should be the approach here? There's another very good problem. I think I just picked up some textbook only. Now already there's a dipole there. So what shall we do? Shall we calculate the field due to the point charges here? But it's asking force on the dipole. There is a problem. So what shall we do? We'll calculate field due to individual point charge at the location of dipole. But again, the dipole, it's a short dipole. We don't have any other information. So what shall we do now? Shall we calculate the force exerted by all these 5 point charges due to dipole? There'll be the mutual, no, it will be. Now look at this negative point charge, where it is. It is present on the axis of a dipole, right? What about these things? They're present on the bisector of a dipole. So we can calculate this distance. We know this distance. Then what force experienced by them due to dipole? Equal and opposite force will be exerted by the experienced by the dipole. Am I right? Look at the approach. Then afterwards, we'll calculate the field at the dipole at point O due to all the point charges. Due to this, how much it will be? Due to this, the field will be in this direction. So I think at the location of dipole, due to these charges, resultant will be 0. Only due to this, it will come. Then go for U equal to minus P bar dot E bar formula, and you can manage. Getting the idea? So there can be questions of these kind also. You have to be very, very extra alert. So I'll do one thing. I will break up this problem into parts so that will be very easy for us. The first I'll start like this. Now let's only discuss about the dipole and negative charge point Q. So there's a negative charge and there's a dipole. So this distance is A by root 2. What is the force experienced by this? We'll calculate F minus. What is F minus should be equal to? F minus should be equal to 2p by 4 pi epsilon naught A by root 2 whole cube into charge, magnitude of charge Q. And how is the field? The field due to dipole will be in this direction. I think let me write E1. There's only E1. Huh? Then how it will experience force? F1 will be in this direction. So what is F1 equal to? Q into E1. So Q 2p 4 pi epsilon naught A cube. This will be 2 to the power of 2 by 3, 2 to the power of 2 by 3 plus 1, 2 to the power of 5 by 3. Check once mathematics. This would be force experienced by negative charge particle. Due to dipole. What about the the positive point charges which are there at corner? They will be similar to like a short dipole. Now, how the field will be in this direction. So what about the force will be F2, and we know what is this distance will be A by root 2. What direction that force will be? That force will be downward. First, we'll calculate what is field E2. E2 should be equal to P by 4 pi epsilon naught A by root 2 whole cube. So then the force F2 should be equal to Q into E2. So QP. Again, this also will end up same thing. One more 2 is there. No, I think I missed. Okay, that's one. Yeah. 2 to the power of 3 by 2 QP or PQ. Just check. I think I'm right. Mathematics, you check once. Okay, this much is what? F2 we got it. So like this, 4 point charges are there. So what is the net force exerted by the dipole on all these 5-point charges? I think F1 plus 4 F2. Four times. Okay, solving this, we'll get the, I think, PQ 4 pi F naught AQ will take outside. This will be 2 square. 2 square again, this will all 5 by 3 or 3 by 2 or 2 by 3? Cube root 3 by 2. I think 5 by 2 it is. Check once. This will be 5 by 2. I think it should be equal to anybody just confirm in the final. Again, this 2, if you send it, the final answer will be 3 by 2. Anyway, just verify it. If it is right, okay, I'll proceed further. What is this F net? By the dipole on all the charges or by all the charges on the dipole? Confirm. Shall I confirm this as answer? Check calculation once and tell me.
Sir, it should be 2 to the power 3 by 2 into 6 PQ by pi epsilon naught A cube, sir.
6 PQ, huh? Why?
It is 5 by 2, it is 3 by 2. That 4 is also there, no, sir. 4 plus 2, 6, no, sir.
Okay, this 4 is there. So this 4 will become 2 square, no? Oh, 2 square, it will be, okay, I think not 1, no, it is a 2 square. Some calculations. How much it will become?
2 to the power 3 by 2 into 6 PQ by 4 pi epsilon naught.
2 to the power of 6 PQ by 4 pi epsilon naught. Can't we write this further? I'll write it in better way. 6 PQ by 4 pi epsilon naught A cube. This much, huh?
Yes, sir.
Yeah, fine. Okay, say nothing big. Already what we know, we have just applied it. Okay, after this, I want potential of system. Not interaction potential between dipole, overall potential. For what we should do for this? There'll be interaction between the charges and also between the dipole. First, we'll calculate how much of energy interaction between the charges and the dipole. I think that'll be easier. So for that, what will be the field due to each point charge at center will be 0. Only due to this it will come. So interaction potential between the dipole and the charge will be only between due to this minus Q and P. Fine. This is the one thing. Next again, interaction potential between these charges. The sum of all that has to be written. So I'll conclude everything. The potential of system should be equal to the negative charge. So this will be minus P Q by 4 pi epsilon naught A by root 2. Please make observation. I'll minimize it. Yeah. See, what I'm doing is like, due to this positive charge, the field due to these two will be equal and opposite. The field due to these two will be equal and opposite. So due to these charges which are there at corner, what will be the resultant field at the position of dipole? Will be 0. Okay, this one. Due to negative charge, the field here will be upward. So angle between P bar and D bar, cos 180, cos 0, 1. So minus P, what is the field due to this will be Q by 4 pi f naught A by root 2. This is due to interaction potential between the dipole and charges. After this, what you should bring? The interaction potentially between them. Between AD, then AC, AB, then DC, CB, then BD, then again the interaction between all these charges with the point 2. UAB, UAC plus UAD plus UBC, UBD plus UCD. This is 1. Then afterwards, 5 interactions. Minus K Q square by A. Able to, what is this? What is the distance between the like a charge which is there at the point O of the pyramid, which is apex of the pyramid, and the corner? The separation is A, no, slant length, and K Q square by like that. 5 interactions will be there by this. I think 4 interactions. Sorry, 4 interactions. This point charge will interact with charges kept at the corner. 4. What about this? These are the interactions between AB, AC, AD, then BC, BD, then CD. Sorry. Resultant of all this you have to calculate. Okay, can you work out? I think the time already 10 it is there. We'll wind up the class. If there in some textbook, you can refer it. Okay, no, so try to work out numericals on the electric dipole and parallelly E equal to minus dou V by dou X, because you have certain idea. So parallelly both try to practice the problems. We'll wind up the class, and after this we'll continue for counseling. Okay, thank you all of you.